Uh, there we go. Hello, everyone. Welcome to the UCSAS 2021 conference and for this workshop, which is Introduction to Python. Um, for now, I'm anticipating that you all have been having a good time with the conference. Uh, so here we'll probably just have a quick introduction to Python, and I hope that you'll also like this part of the conference. So about me, I'm a third year PhD student from Department of Statistics at UConn, and I'm usually interested in stochastic processes, and my research area is in that particular field. I aspire to be in research and academics, and have hobbies such as playing sports or painting, traveling. These are the things that I pretty much like a lot, apart from, of course, the research itself. So the prerequisites for this particular workshop is just that you need to have a laptop with Anaconda installed. I hope you all do have that. Do any of you not have Anaconda installed? In case if it is not downloaded and installed, you can download it from this particular location. And in case if you are thinking, where do I get these slides from? These are at the GitHub location, which I'll share with you on the uh, on chat. So let me quickly get to the chat. So that is for Anaconda for Windows. That is for Mac. And you can also get the slides and everything else from the GitHub repository, which I have also shared on chat. Okay. So the prerequisites are basically a laptop with Anaconda installed, and I'm hoping that everyone do have that at this point in time. And in case if you're taking some time to do that, please just download it on the site and we can go ahead. So what is Anaconda? So it's a GUI. It comes along with Python 3.8, by the way, which is not the latest one. The latest one, I think, is either 3.9 or 3.10 at this point in time. It also comes with some pip and conda forge, which are package managers, which allow you to kind of have different versions of the different modules and all of that. And some of the important modules such as NumPy, SciPy, Matplotlib, those that are commonly used often. So Anaconda installs along with those things. So you can also separately download Python and install Python on your computer, except that for the first time when you need to use these modules, you will have to be installing them as well onto your computer using pip. But if you are taking Anaconda, which is a bulkier version of a GUI, it consists of all these basic modules. So the advantages with pip and Conda Forge, one of the predominant advantage is basically being able to create environments. So environments are different. Environments are where we have particular versions of a particular module. For example, let's say NumPy has gone through multiple versions, and maybe there is a function in NumPy's older version that you are very much interested in and you've used predominantly. And maybe it's gotten deprecated at this point in time, which means that it has been changed or removed or things like that. So in order to not affect your own research, you may want to have an older version of NumPy in a particular environment where you've used it. So therefore, environments allow you to have these different versions of modules in separate environments that you create, so that even functions that are deprecated also can be utilized. So having said that, Anaconda also gives you Jupyter Notebook, which is a very useful tool in data science. It is similar to R Markdown. If anyone has used R Markdown, it kind of has both Markdown syntax where you can write text and follow it up with code, which can also be run. So Jupyter Notebook gives you that elegance of writing a report along with the code and the results right next to it. Having said that, I know that this is a workshop, and therefore, if you have any questions at any point in time, please feel free to chat and write it down in the chat, and we'll stop where we are and probably talk about that. So, I mean, furthermore, one of the other advantages of having Anaconda is that Anaconda will give you these different learning tutorials. It gives you tutorial for Python. It also gives you tutorial for most of these important modules that you will be using very much if you are getting into Python, which is, for example, pandas or NumPy or things like that. So you can go to the learning section on the left, and you'll see that there are a lot of references there as well where you can learn from, like tutorials where you can learn from on the go. So having said that, let's quickly get to the motivation of why we are doing this. Of course, I mean, there should be a good reason why we are learning a new language. So one of the reasons is data is growing a lot, and therefore a lot of application of data science. It need not mean that we need a new language, but overall, Python is one of those languages that can be applied to data science. Apart from that, Python is also very easy to read and write. It is some of the syntax in Python is almost like English, reading a line in English. Like, for example, you can say a string starts with, dot starts with. It's a method for a string. It kind of gives you a very easy to read and write sort of manner language. So, and a lot of deep learning models have been implemented here, and therefore there is a lot of demand for Python. Also, in a lot of fields right now in the industry, there is a lot of interest for Python. And last but not the least, we need to survive in the job market. For us to survive in the job market, it's always important to be ahead on whatever is going on. So Python seems to be the new thing, and therefore we should be on top of it. So quickly, a glimpse of how the data is being created. Like every 1 minute of a day, you can see how many tweets are being created, like 575K tweets. And so this is a small, this is a survey so this is a visualization by Domo. You can see that how much data is being created in a minute of a day. So that just shows you the vastness of the data. And you can see that there are language rankings. So, and within these rankings that are being given by IEEE, you can see that Python is right now at the top as the most, as the best ranked computer language. And also, you can see amongst a smaller sampled survey, which is only on a survey of 3,000 people that has been conducted by Anaconda, you can see that Python has been mentioned as being used quite often. And that probably is because it's becoming an increasingly popular language. So a little more intro, maybe. So Python itself, we should give history its importance. So Python has been released in 91 by Guido van Rossum, and it has been, since then, it has been useful in so many different things like web development or software development. And nowadays, predominantly, we do see it in data science. So it has a very easy syntax. And the most recent major version is Python 3.10. Although there is a Python 3 version and Python 2 version, in case if you are getting confused. And the Python 2 versions are often seen in MacBooks that are already there, and those are the ones that are used for development of few things on Mac. But if you see outside, predominantly Python 3 is used because they get mostly updated often, and also that a lot of modules are written in Python 3, so therefore it makes sense for you to probably use Python 3. So, and we can use Python a few different ways. For example, just a quick heads up: if you have a terminal or something similar to a terminal, like a command line, you can just say, you can type in Python, and you can see that there is a version of Python that has opened up on the command line itself, where you can do calculations like 2.3, 2 plus 3 is 5, and so on. But there are also IDEs such as similar to RStudio, like PyCharm. And then there is this Jupyter Notebook, which is very predominantly used. Okay, so the aim of the workshop. So the aim of the workshop, we'd like to just get into some basics of Python. For example, we'll just look through what a variable is, what indentation needs to be there for Python, or does there need to be any indentation in the first place, and a few data types that are there in Python, and loops and all of those things that are primarily, required for any computer language. So we'll just get through those things. And amongst modules, we'll probably touch upon NumPy and Pandas, at least that's the hope, and we'll end up with a quiz. So now let's get started. We'll be working on Jupyter Notebook. So if you go, I hope that you all have Anaconda. So if you have Anaconda, you can switch it on. If you open up Anaconda, you should be able to see that Jupyter Notebook is an available option there. You can launch Jupyter Notebook. On the other hand, I also hope that you have gone to the GitHub repository. If you do go to the GitHub repository and if you clone this or download this, you will see that there is a practice.ipynb. It's called Interactive Python Notebook. So those are usually opened using Jupyter Notebook. So you can download it first. And once you downloaded it, from within Anaconda, launch your Jupyter Notebook and try to get to wherever. Let me clear these out. So try to get to wherever the practice notebook is. So for example, in my case, I do have it in UCSAS Intro Python, and there's this practice.ipynb. It's pretty much an open notebook, empty notebook at this point in time. But as we go through the quiz problem, we'll probably be working here. As well as if you want to try out any code, you can try out in the empty code sections that you have here. So until now, are there any questions? Okay, so let's get back to the slides. So I think in the first few lines in the practice notebook, I've kind of had a few useful comments for Jupyter, because you're trying to use a Jupyter notebook and a lot of people use mostly keyboard shortcuts on there, and you should try to understand what those keyboard shortcuts do. So for example, if I'm going to a new chunk like this, and if I click on top of it or press enter on top of it, you see that it's all covered in green. So green basically implies that it is in what is called as edit mode. Whereas if I press escape on top of it, it turns to blue. If I do an escape on top of it, it turns to blue, which means now it is on a command mode. So on command modes, you can tell the notebook itself to create new chunks. For example, if I want a newer chunk below it, I can just type B and it creates a new chunk below it. Whereas if I want a chunk above it, I can type in A and it creates a chunk above which one you've highlighted. Okay. And on top of it, if whenever it is written in something, that basically means it's a code chunk. So there is a difference between code chunk and markdown chunk. Like for example, markdown chunk allows you to write these things over here, whereas a code chunk allows you to write code and run the code on Python. Okay. So when you want to modify this code chunk, because you know that this is a code chunk, into a markdown chunk, you can type M while you are in the command mode. Okay, so command mode allows you to make changes to the code chunks that you have. So if I type M, you can see that the in something has been removed. That basically implies that now it's no longer a code chunk, it's a markdown chunk. So in case if you see, try typing double hashtag here, you can see that it is much different from how it is in a code chunk, right? In a code chunk, hashtag usually acts as a comment, whereas in a markdown chunk, hashtag acts as a heading. So single hashtag means it's the primary heading. So if I say, for example, just heading 1, and if I do a command enter, you can see that it converts to a heading over here. And you can also write down text over here. For example, I can say, hi, we are learning Markdown syntax. And you can also say use, for example, you can also use bullets. Say, okay, the first point is to know how to change a chunk to Markdown chunk. So you can see how it changes into Markdown, into the headings and all of this. So these are all Markdown syntax. Whereas anything that's written in a code chunk that has an in something is a Python syntax. For example, you can here start writing a new Python command such as print hello world. And if I press command enter is a shortcut for basically running this. And you can see that it runs as the first code chunk that has been run. Now you get a number inside in within the brackets, and it says that the result is hello world. Okay, or not the result, but it says that it just prints out hello world. So these are a few things that you can know about Jupyter Notebook, and you should know how to move between command mode and edit mode, and how you should be able to how you should be able to create new chunks or convert chunks. So for example, if I wanted to convert a a markdown chunk into a code chunk, on the other hand, although I do not want to, in this case, let's say if I've written some code, but this has been a markdown chunk, I can use Y on the command mode, and that should again convert this into a code chunk. Although since I don't want, I'll be converting it back to a markdown chunk. And here it is now a markdown chunk. Okay, so having said that, these are a few things about Jupyter Notebook. And if you wanted to know more about Jupyter Notebook shortcuts, because you do not want to remember all these things, you just need to get used to them, and then it'll become easier. But an easier way to find that is whenever you are in blue, which is command mode, if you try to type in H while you're here, maybe if you're trying it out right now, you can do it. If you try to type in H, that allows you to look at all the shortcuts that you have under different modes. So under command mode, which is enabled by escape, you have these shortcuts. Under edit mode, you have these shortcuts. So you can try looking through a few of them. Okay, so having said that, let me quickly delete them. And a shortcut to delete is going to command mode and pressing double D, and that should delete those things. Okay, so having said that, let's now move on to the next part. So you can there are a few code chunks that I have on my slides, and maybe as we go along, you can try out a few of them, and that should be more like helpful to let you know how you can use Python in there. So make sure that whatever code chunks we are running, those should be in code chunks which are not markdown. So therefore, you should definitely make sure that they have an in and brackets over there. So let's see, how do we find out if Python installation is there? So in order to check for a Python installation, if there is a Python installation, you can use this particular command that says that starts with an exclamation. And by the way, the reason why we use an exclamation is because exclamation is equivalent to using any command on the command line. So or on bash. So it's basically trying to run Python and version on bash instead of on Python. Okay, so although this is a code chunk which is a Python code chunk, if you try to use an exclamation in front of it, it becomes a bash code chunk rather than a bash line rather than a Python line. So you can say exclamation Python version, and that should tell you that this the one that we are using currently is Python 3.8.8, which is what you get in Anaconda. So now again it's in blue, which is in command mode. So I can create a new chunk right next to right below it using a B, and I've done that. And let's okay. So now let's move on to syntax. So Python often uses new line to inform end of command or function. So if you move on to the new line, it means that the previous line function has ended or previous line command has ended, except if the new line, if the next line had some indentation. Okay. So this is not like other programs where for functions and everything, you create semicolons or brackets. For example, if you're someone who used R, you will see that for function, the scope is defined based on the curly braces, whereas for Python, that's not the case. So, and also I think most often, because along with our code, we often write our comments. It's important to know how we write our comments. Either you can have, you can use double hashtag or single hashtag. A hashtag basically makes anything into a comment. But an easier shortcut to be used in Jupyter Notebook is command plus forward slash. So for example, if I've written, okay, this is a comment, and you can see that this is, I mean, you cannot do that on Python usually, but you want this as a comment. So I can just convert it into a comment by using command plus forward slash. The one that is next to greater than sign on my keyboard. I definitely think others will have different keyboards. So apart from that, so you can see an example, a quick demo. If I've written print hello UCSAS and then print workshop is going good, these are two different lines of code, and Python considers the first line, and as soon as you move on to the second line without any indentation, it thinks of it as basically the end of the previous line. So, and then let's move on to indentation. As we all know, I mean, Python uses indentation for the loops or for functions and things like that. So it's basically the amount of spaces that are required at the beginning of the code, just to inform that something is still continuing, right? The code that you're writing is still not complete. So you have to use white space, and often it should be at least one space. Although on Jupyter Notebook, if I'm trying to write a loop or something like that, so for example, if I say if x greater than 10, and soon after that, if I'm going to the next line, often it already does indentation automatically by by actually 4 spaces. But otherwise, even just one space should be sufficient. So, and also if you are using, if it's the same block of code, you would like to use the same number of space. And so you can see an example here. I've used just one space. I have a code such as x equal to 0, and then I have an if conditional to print something, and if and else for printing something. And using just one space allows Python to think that, well, this is the if is still continuing, okay, without using any braces or anything like that. Okay, so if you're there, you can give it a try, trying to run this, checking if there is any problem. And if you are getting any problem, definitely let me know, so that we can correct any problems that you face. Okay. So, and one of the most important things is obviously how to find help in Python. So there are a few ways on which you can find help. So the first thing is, if you don't even know what the function, what function you need to use, obviously you need to Google through or find tutorials. But if you know the function but don't know what its usages or what its parameters are, you can often use help of that function. But if it is part of a different module, you should use the module dot function inside help for you to get information about that function. Okay, so, and also the other thing is that there are various methods in Python for every type of data. And if you want to know what methods are there, you can always try typing in dir of type. Those kind of give you all the attributes of that type. So therefore, these methods are some sort of small functions that you can apply. For example, an append is a method that is applicable to a list. So if I created a list and if I wanted to know if there is an easy way to add something, I can always type in dir of x and it'll tell me that there is an append method, there is a sort method, and so on. And I may use one of those if required. So here is a quick example. So if I have my class being list, it's just and I would like to check all those methods. So here I'm trying to create a, a list of all the methods that are in the directory of my dir of my class. So by doing dir of my class, I usually get all the methods, and in which some of them will start with an underscore underscore, which are something that I'm not very much interested in. So if I want only those methods that are that I'm interested in, for example, uh, not the I mean just like append or these things, I could probably try to create a list of all the methods by saying if method starts with underscore underscore is false, you then it'll give me only those methods in my dir of my class that don't start with underscore underscore, which happens to be append, clear, copy, and so on for a list. Okay, so this is one way to find out all the methods for a list. So this can be applied not just for a list. If you have an object that is a string and you want to know what all methods can be applied to a string, for example, this starts with is a method that is applicable to a string. Because my method itself is a string, I know that I can apply method dot starts with. Okay, so these are the things that you can try and find out. Okay, so now a quick quiz on help with variables. So I would like you to try to use the above manner of using dir to find all the methods that are applicable to class list, which we have already seen, by the way, and apply those that are appropriate for the following task. So first, create a variable x, which is which has a list of 3, 10, and 7. And using the methods for a list, try to concatenate 4 to the list, which means append 4 to the list, and then try to sort it in descending order. Once you add a concatenated 4 to the list, try to sort it in descending order, and then remove the item at index 2 and clear the entire list. So take maybe 2 minutes, or sorry, 5 minutes, and try doing this. And if you are not so sure about a particular method, for example, a pop or a remove or things like that, which one applies to removing an item at index 2, for example, you can just say help of the variable name or the type name dot method, and that should basically help you find out about different methods. For example, if I do help of x dot pop, it tells me about the pop method. If I do help of x dot remove, it tells me about the remove method. And you can see which one applies here. Just in case if you do not have it. Is anyone able to get to an answer? So maybe an answer wouldn't make much sense because I've just asked you to append 4 to the list and you may have done it already. So, but can someone tell me what function did you use to remove the item at index 2? Did you have to use pop or remove? Any guesses or any answers? Okay, so let's quickly check it out. So if I want to initiate a list, by the way, a list is created by square brackets. I can create a list x is equal to 3, 10, 7. And I just printed out all the methods that are not starting with underscore underscore, and that is the code from above. And you know that for the list you have append, clear, copy, count, extend. These are the different methods that are applicable to a list. So, and append seems pretty obvious to kind of concatenate a new number to it. So if I do x dot append 4, it kind of appends 4 at the end of the list. And then if I want to sort it in ascending order, I know that I can use x dot sort. There must be an extra parameter to kind of make sure it is descending as well. But I thought I can use, once I do x dot sort, I see that they're all sorted. X itself is sorted. You can see that you don't need to equate it to y or things like that. X itself gets sorted. And then if I want it in reverse order, I can just say x dot reverse, and therefore it becomes descending order. And application of pop and remove. Pop usually uses the index, and therefore it removes whatever value is in a particular index. So in order to do that, you need to understand how indexes work. Uh, so in Python, by the way, indexing starts at 0. So for example, in a list like this, the 0th element is 3, the first element is 10, the second element is 7. Okay, so if I want to remove an element at index 2, it basically means it's the third element, and I can easily remove that by using x dot pop of 2 that uses index. The second element will get removed. Whereas if I want to use x dot remove of, then I should be giving in the value that I want to remove from the list rather than the element. And if I have multiple occurrences of a particular value, it will only remove the first occurrence of that value. For example, if I have 10, 7, 3, 3, 5, 3, and so on, it will only remove one value of 3, but not all the 3s. And by doing x dot clear, I can clear the entire list. I can create an empty list at the end of it. And like I told you, you can use help of x dot pop or help of x dot remove to get more information about how you, about those particular methods that are applicable to that list. Okay, so let's move on to data types. So we have a few data types. I can probably rush through a bit of this. You may have already seen that there will be a string, there will be integer, float, complex numbers amongst numeric, and amongst sequence-like types, which are basically which contains multiple items, but also in an order of sequence. There are list, tuple, and range. And amongst mapping-like items, you have a dictionary, which is often written as dict. And among sets, you have set, and for Boolean, you have bool, which is basically a true or false, right? A logical. So these are all the different data types that are already existing in Python, in the default Python, without any modules itself, okay? So apart from these, there might be more data types as and when you create a module, and even you can create your own data type if you wanted to. So uh, how do you find out a type of a particular data? You can click type of something, and that tells you what data type it belongs to. And probably that is going to be extremely important when you have a huge data set and you want to know each column whether they contain numerics or whether they contain something else. You can easily use type of to find out what it contains. uh, so quick illustrations of data types. So for string, as we've seen, string saves everything as an array of bytes. So therefore, although it seems like it's just characters, it actually saves it more like an array. So if you have, let's say, apple, you can actually access the access each letter in that string. So if I use square brackets on a particular variable that is a string, I can access, let's say, the second element or the first element or the third element in that particular string. So that becomes predominantly very, very important, especially when you're trying to search through an entire string to find, let's say, numbers or things like that. You can easily search through and access those elements because you can access them like an array. So if you want to create a multi-line string, you can use 3 quotes. That's something that may not be as important. And if you use a plus, it usually concatenates 2 strings. For example, if I have a string x is equal to this, let's quickly do this. If I have x equal to this and y is equal to apple, maybe with a space, and then if I do print x plus y, it should give me this apple, right? And also, like the way I just informed you for strings, if I do x of 2, it should give me I, because as I told you, this is the 0th location for Python, and then the first location, and then the second location, right? So at index 2, I have I can access that by using this. Okay. And for strings, there are various, I mean, actually too many methods, and most of those methods can be extremely helpful. You can find out if the string is actually made of alphabets, if it has digits, or if it starts with a particular thing, or if it ends with a particular thing. And you can also strip any blank spaces at the start and the end, and you can even capitalize the strings and so on. So for strings, it can give you a lot of information. um, so here I just created a string and have used the fstring method to kind of give us a result of what type it belongs to. By the way, why do I have a print f and then quotes? These are called f strings. If I have an f and then quotes, so what they allow us to do is they allow us to use these curly braces to include variables within the strings. So I can then format X to be whatever that ABCD is that gets replaced in here. So I'll get ABCD is of type. Type of X is a function that is applicable on X. So I want that to be run and then the result to be obtained here. So I can get that is class of string. Is that clear? So I can use these F strings, which are F followed by ports, to kind of use format both strings along with outputs or other variables. So like I told you, multi-line string can be applicable using 3 quotes on either side. And for accessing and slicing, you can access string either one number or one letter of a string or multiple letters of a string. By the way, I used this just yesterday to kind of get some result from an entire line. So it can be helpful. And by the way, is to 4, 1 is to 10 basically means index is 1 all the way to index 9. So is to kind of works slightly differently here. 10 does not mean you will get the element in index 10. You will get until element in index 10, which will cut off at 9. So you'll get the element that is in index 9, but not the 10th one. So apart from that, you can also use is to 4, which means from the start till the index 4th element, which again does not include the fourth index element. It will only go till the 3rd index element. And you can also go with 4 is to, but in this case, if the starting element is there, that is always included. So 4th element in this case is included. Okay. And you can also use negative indices to kind of get the last characters. Okay, so I think We have many other things like integers, float, and complex numbers, and also Boolean numbers, which are true or false. And then we get to a data types containing multiple objects like list, tuple, or range, or set and dictionary. Uh, Predominantly, as you can see, list can contain all types of elements in it. You can have numbers, you can have another list, you can have strings, and all of that. Tuple also allows to do the same thing, except that tuple is what is called immutable, and we'll get to what mutability is in just a few minutes. But tuple is what is called immutable. And apart from that, we have set. Set cannot have uh, anything repetitive, which means it can only have anything once. Set can be created by using uh, immutable elements only, which means it can have a set of you can have a set of tuples, but you cannot have a set of lists. uh, so that is also something that you can keep in mind. There's a lot more information that you can probably read through whenever you get time, and it's kind of a lot of information there. So for tuple also, all these data types also have methods again. So if you have a tuple, I can count all those values in the tuple. But like I told you, tuple is immutable, which means it cannot easily be changed. That's basically what it tries to address. It cannot be easily changed, which means I cannot change the values in a particular location in that tuple. So oftentimes it's easy to use mutable types, but sometimes you may have to use immutable types, such as in a set you cannot have mutable types, for example. And then range is an element that basically are a set of integers, a sequence of integers. You can give range of start, stop, and step, and that can create a set of a list of integers. And you can see that but for range, you will see that it only represents it like this, range of 1,5. It doesn't give you the give it to you in a list manner. And by the way, just to remind you guys, a tuple is created using like open brackets, whereas a list is created by closed brackets. And moving on, we move on to set, which is created using curly braces. It is usually understood to be like a set. It cannot have repetitive elements. It can be, for example, the set of all those people who attended this workshop and who attended in a different workshop. So you cannot have any name or any ID that can be repeated, right? So therefore, sets will always contain elements that are unique. You can include an additional element with the same value. What set does is it usually replaces one of them. It just removes the other. So for dictionary is kind of like a key and value mapping. So it's written more like a set, but then it has a key and is to value. So again, these keys have to be immutable. So therefore, they can only be, for example, either numbers or more primitive things like strings or IDs or things like that, or they can also be tuples. Tuples such as, 2015 Atlanta, 2015 George, some other, like, New York, things like that. So you can have a tuple as a key as well. However, you cannot have a list as a key, for example. So those are the things that you can see that happens to a dictionary. So you can access all the dictionary keys by using dict.keys, and you can access all the values by using dict.values. So like mutability and immutability, as I was telling you, primitive types like integer, float, and all of these are immutable, which means if you're trying to modify it, then they are now the address of that particular element changes entirely. Whereas mutable elements, there are a few, which is like the list is, for example, a mutable element. A set is a mutable element. These allow changes to happen right at the same address. So how do I know what happened to the address? ID is a function. You can use ID of a particular thing in order to find if the address changed or not. And also you can use the function is, it's not a function, it's a keyword is, to find out if the address is the same or not. So instead of double equal to, so for example, if I do print of id of x, print of id of y, it gives me the address, exact address. Whereas x is y, x is z, they usually tell me if they both actually are from the same address or not. We also have multiple operators, which you may all be aware of, the addition, subtraction, and all of those things. But they work differently for lists. For example, if you have two lists and if you do an addition operation, it doesn't do a point-wise addition. Rather, it actually concatenates those two lists. So you should try to understand what operators do for different type of objects. You can cast data from one type to the other as long as they're reasonable. A list and a tuple can always be cast to one another by just using list of and giving an input of a tuple. You can create a list that has the same elements as a tuple. Okay, so for conditionals, let's move on to conditionals. If I want to write a conditional, I'd usually do something like this. I'd write if, and then you can have an and or an or, for example, in conditionals as well. But then at the end, you need to have a column, and afterwards you need to have indentation in the next line to kind of write whatever should happen within the conditional. And you can also have if, elif is like else if, and then else. So moving on to a while loop, then we have while loops and for loops, things that you may be aware of if you had some computer knowledge, is how you create a while loop or a for loop. So you have while works as long as a particular condition is met, whereas a for loop actually accesses iterates over some values in a particular in some values in a particular list or things like that. So for temp in x basically goes for it goes on as long as temp is each value in x. So then we create functions. A way to create functions in Python is by using the def. So you can create a function using def, and like this, for example. Again, you need to do indentation as you do with if or else as well. And %time it, by the way, is a shortcut to find, is a profiling manner to find out if, how long it takes. It does multiple runs, like 100,000 runs, for example, in this case, to tell you how long it takes on average and how much standard deviation do you have to run this particular function on Python. That helps you to find which one is faster. Lambda is sort of like a function, but a much one-liner function more so. You can have a one-liner function depending on only one parameter, and that can be lambda. So after this, I think I've gotten short on time. There are these few modules that are very, very important. NumPy, which is very famous for arrays. It creates matrices or like a one-dimensional array or two-dimensional arrays or things like that. You can create using different functions. np.ones creates a ones. np.arange creates a sequence of numbers like 1 to 10 or things like that. np.I creates an identity matrix. And NP also is famous because it has all the a lot of functions that can be applicable directly on a vectorized manner on these arrays. So you can do exponentiation on the entire two-dimensional array or things like that without having to create a different function for it. So it has a ton of functions as well. And it's also famous for the submodule that random is, which allows you to kind of create random integers or random variables from different. So after NumPy has been shown, there is pandas, which is more close towards what we have in R, like dplyr and things like that. We can create data frames in here, and those data frames, we can filter those data frames. We can do a multitude of things that we'd like to do. For example, select a few variables, filter it, and all of those things can be done on pandas. So if you want to usually use pandas, if you already have it installed, then you would like to still use import pandas and you want to use an alias as PD or something like that. And that PD should go along with every function that you're using in pandas. So you should write pd.series to kind of create a series. Or you write pd.dataframe or pd.read_CSV in order to use it. So, and then we have a batting data set. I think I'm sure I'm over time. So we have a batting data set, and you can try to work on this quiz, and probably if you get to your results at the end of it, although the results are kind of written here, but I'd like to see if you have a different take and if you want to try it out differently. There are various functions in pandas that you can try out and see how you can just view the head or describe the data set or merge data sets and also derive different variables. And then you can also use Seaborn, for example, to kind of create line plots and things like that. Having said that, these are not the only modules. There are many more modules. For example, scikit for machine learning algorithms, matplotlib, plot9, and Seaborn are probably some of the data visualization modules. Request does web API things, and TensorFlow allows you to do dense neural networks. And you have image processing modules. So there are so many modules that are already created and can be extremely helpful for most of your projects that you plan on doing in Python. So, and I think that's my time. I hope you all had a great time. Thanks for the patience and enthusiasm. And sorry that we did not get to the actual workshop bit of it, basically working on the batting project. I hope you'll all work on it. And if you have questions, definitely ask me about them. And I'll be available at surya.ita@ucon.edu. Thanks for all the time.